Okay, in this problem, they say all this, but what we really need is that this is the joint PDF, and we need the variance of y given x equals 2. So for this variance, we first find little f of y given x equals 2. And if we think about it, we've done this a few times before, but just to recap, that this means y is it's y and x equals 2, f of y and x equals 2. So which basically means f of 2 comma y. So the joint PDF at x equals 2. That's what f of 2 comma y. And then in the bottom you have the density of the marginal density of x at x equals 2, so fx2. So that's, in a way, you can think of it as probability x equals 2. That's not quite the same thing, but it's a way to remember it. So fx2, we first do fxx, that would be negative infinity to infinity of the joint PDF, and you do that integral with respect to y. So again, to get the marginal of x, you integrate y out of the joint PDF. And to see the y bounds, we draw the region. The region was x greater than 0 less than y. If we look here, x greater than 0 less than y. So x greater than 0 and y will also be greater than 0. So it's the first quadrant, and then x is less than y. So y equals x is this line, and x is less than y is the region to the left of the y equals x line. And to look at the y bounds, which is what we needed, that's why we drew the region, we draw a vertical strip, and we see that the lower end of the y is at x, while upper end it keeps going. I've stopped it at some point because we have to stop on the paper, but actually it keeps going. And so therefore the y bounds will be x to infinity. So x to infinity, and then you integrate the joint PDF, and that's fx of x. And then to get fx of 2, which is what we needed, you substitute 2 for x. So 2 goes in the limit here, and 2 goes over here. And here, it's a linear exponential function, and the shortcut to integrate a linear exponential function is you just repeat the exponential function, and then you divide by the coefficient of the variable. So here the coefficient of the variable, if you open this up, would be negative 1 over 6. So you divide by negative 1 over 6, which is like multiplying by negative 6, and then the exponential part stays as it is, and 2 to infinity. And then you substitute infinity, you get e to the negative infinity, and minus, when you substitute 2, that's e to the negative 4 over 6. E to the negative infinity we know is 0. And so that simplifies to 1/3 e to the negative 2/3. And now we have everything that we need. So f of 2y, as we said, we substitute 2 in the joint PDF, so we get 1 over 18 e to the negative 2 plus y. Remember, there was x here in the joint PDF, so substitute 2, and then fx2 we just calculated here. And now combine the two exponential. 1 over 18 over 1/3 is 1 over 6. And this is negative 2 over 6 minus y over 6. So that's negative 1 over 3 minus y over 6. And then this comes up as plus 2/3. And this simplifies to plus 1/3 minus y6, which can be written like this if you do a common denominator. So negative y minus 6 by 2. And now if this negative 2 was not there, if it was just 1 over 6 e to the negative y over 6, that we know is the PDF of an exponential with mean 6. And we know that for an exponential PDF, the variance is the square of the mean. So the variance of this one is 6 squared, which is 36. And now this PDF, which is what we are looking for, it is just the same as this basic PDF, but it's shifted horizontally. So anytime a PDF has a horizontal shift, then its variance is the same as the original PDF. So a horizontal shift of a PDF does not change its variance. So therefore, the variance of this one is also the same as the variance of this one, which is 36, and that was choice C.